So hi, yeah, this is what we're going to make, a text-based particle system using POPs. And you can see that there's all text arranged. It kind of switches between being sensical and then organizes into this random arrangement of random characters, which will later go back into create the readable text again. And we've got this sign-based scroller. And also attached to the mouse cursor is this sphere, which creates waves and randomizes the characters and the colors and things like that. There's two main components to this. There's a particle system using POPs, and then there's the text, and the text is using UVW coordinates. And there's nothing unique to POPs about this, actually. It's just using standard geoinstancing. We could equally create this with top-based particle system, or even SOP or CHOP-based particle system with geoinstancing, but it is a lot more pleasant using POPs. So let's get into it. Here we are in a completely empty Touchdesigner project. I am using version 25.360 experimental, which was released Friday, June of 6, just a week ago, a couple of weeks ago. So POPs are experimental. This might change, but as I said, the basic principles will work even with SOPs and CHOPs and everything. So first, I want to talk a little bit about UV mapping, UVW mapping. I'm not going to go too much into it, but just to provide a basis, I'm going to create a rectangle POP. It could actually be a SOP as well, but I'll just stick with that. And let's say that I put this into a geo, and let's create a movie file in top. And let's load something like this one. Okay. Let's put a null on that, Alt-N. And let's create a material. Fong will do. Color map, and put that material on that. So all I've done really so far is I've assigned this as a texture onto this material and onto this rectangle. Now, in this case, this image is mapped onto the entirety of this rectangle. The reason that happens is because of UV coordinates. Now, if I middle click on this rectangle, you can see that I have 3 point attributes: P, which is the position; N, which is the normal, the direction, I'll skip that for now; and tex, which is a float3, which is the UVW coordinates. If I'd created a SOP, let's create a SOP rect actually. So now I'm creating a SOP, and let's also put this on a geo. Let's apply the same material. It looks the same. Now, just by convention, there's nothing specific about this, but the Touchdesigner developers have defaulted to putting the UV coordinates, the texture coordinates, they're used interchangeably, texture coordinates, UV coordinates, the same thing, on the vertices instead of the points. And they've called it UV for SOPs. For the POPs, they've called it tex. It's the same thing. Also on SOPs, they're by default added to the vertices, not the points. Whereas on POPs, by default it's created on the points, but you can change it. Texture coordinates, see here, instead of points you can say create on vertex. Now it's going to be created on the vertex. This is detail, it doesn't really matter, it's just a slight difference. I'm not going to go into the reasons as to why that's relevant, but let's just leave it at the default and I'll get rid of this. And in fact, one thing I will do is I want to, let's add a null here. Okay. And I want to add a pop to DAT. And I'm going to split this into two, make this that, and then put that there so we can see what's going on. So my rectangle has 4 points, 1, 2, 3, 4, and each point has a position, a normal, and a text. Text is float 3, and we can see it here. What this is doing is it's basically saying what part of this image should go with what part of the point. So if I put, for example, a math here, and I want to do some maths on not P, like if it's on P, then if I kind of go like this, look, I'm changing the coordinates, the physical coordinates, but I want to do it on text. So now, if I, for example, add something, you can see here that this is shifting because I'm changing what part of the texture to use, and you can see here that the texture coordinates are changing. Let's reset that. Let's say parameter size 3, so that we have 3 of them. If I change just this one, I'm changing just the X. You can see here. This is just the Y. And then this one is the Z, which is actually not doing anything right now, but it will. So these are also called U, V, and W. So this is the basics of texture mapping. This is how we decide what part of a texture maps onto a polygon or a face. For each point, we specify what the texture coordinates should be. So this is standard UV mapping. Now, we can also do UVW mapping using 3D textures. And if I go to top and create a texture 3D, the way texture 3D works is, it's a bit like the cache top, which basically accumulates the incoming textures. But so let's say that I have a movie file in, and let's load this video. Okay, so there we have a video. So the cache top is basically caching the incoming frames. The cache size is 32, and I can tell it to output, for example, 20 frames ago. So you can see there's 20 frame difference. But this is just stored in like an internal, this is just a Touchdesigner, bespoke Touchdesigner format. Whereas what Text 3D does, let's play. Text 3D also caches the incoming image stream. Here I can specify again the cache size is 32. Let's make that 16, so it's 4 by 4. And let me stop it. So what this is doing is it's storing the last 4 incoming, not 4, the last 16 incoming images. It appears to be tiling them, but if I middle click on it, it'll say that it's 640 by 360 and the depth is 16. So this video is 640 by 360. So this is 640 by 360 with the depth is 16. It's better to think of this not as a 2D array of pixels, but as a cube. And it actually has depth. And this is what we're going to be using. This is a 3D texture. So what I can do is, if I, instead of do active, so if I get rid of active, it stops. I can do prefill. And if I do prefill, then it basically prefills it. So it takes 16 frames and then it stops. But instead of feeding it a video, I actually want to, just to make life a bit easier, I want to do text. Let's get rid of that. And here in text, I want to write a Python script. Let's try me.time.frame. Okay, let's do int. Okay, so this is just increasing numbers, and let's do on the text, let's say cache size is 10. Oops. And let's prefill. Okay. So we have 1 to 10. And the actual shape doesn't matter, the fact that it's 4 by 3, because again, it's actually 256 by 256, and the depth is 10, so it actually has a depth. And let's make the text bigger. So let's do fraction 1. Okay, let's prefill. Okay, make it a little bit smaller. In fact, let's do here on the text. Where was it? Let's do -1, so it's 0 to 9, and let's prefill this again. Okay, so we have 0 to 9 there. So this is our texture. Now, let's take this, put it down here. Okay, so this is our texture, and you can see that we're seeing somewhere between a mix of 8 and 9. So first of all, in this 3D texture, there's two types of 3D textures. There's 3D texture, and there's a 2D texture array. And if I change it, you can see it changes. 3D texture has now, both of these actually have, you can think of it as a cube. In addition to UV coordinates, there's also a W coordinate. So let's start with 3D texture and go back to this math. If I play with this, you can see I'm playing with the U, not the V, but the Z coordinates. And as I go through this, it's going through all of these. And you can see it's cross-fading. So if this is set to 3D texture, it interpolates in the depth dimension. And the range of that is, the range of the entire depth of the cube is 0 to 1. So 0 is here. If I go to 1, it's going to be the same. 0.5 is going to be exactly in the middle. And let's go slowly. So there we are at 9. As I go slowly, it's going to go to 0. So here we are at 0, going slowly to 1. 2, etc. So this is a normalized coordinate, 0 to 1, from the first to the end, and that's if it's a 3D texture. If, however, we pick 2D texture, then the W coordinate is an integer, and it's not interpolated. If I go through this slowly, you can see it's still 0. Oh, we just passed the halfway mark, 0.5. It's rounded to 1, and we get the first one. And I go through again, and you can see. And here you can see the text coordinates. So basically, this is just the, we can still play with the U coordinate to shift it horizontally, vertically, and now in the Z, the depth, which is W. So this is the basics of UVW mapping, and this is what we're going to use to create a particle system where every particle is going to have a W attribute, and that W attribute is going to refer to a different depth in the UVW map. We could do this with chops and tops and SOPs, but let's do it with pops. So first thing, let's create a pop point generator. This generates a bunch of random points. Well, it doesn't have to be random. You can choose for it to not to be random, but let's create not too many to begin with. Okay, about 200. And add a null to that. Let's call this null points. Go to this geo and enable instantiation. Put our null points here and tell it to use the position from X, Y, whoops, P1 for Y, P2 for Z. Okay, so this is standard instantiation we're doing right now. Let's make this rectangle a lot smaller. This is the original rectangle here. Let's bring it down. And actually here, on the right side, come on, I want to split this in two, and I can make, Let's make this bottom one a geometry viewer. Okay, so I've made my rectangle size 0.2, and I've got this up here as well. Actually, this pop2, instead of looking at this, I'm going to move this up here, and I want to look at my null points. Oh yeah, I'm not playing. Okay, there we go, sorry. So now this table up here is looking at these points. And we can see that we've got position and normals, and there's 230 points. I should warn you, by the way, when you have millions of points, you shouldn't do this. This will be super slow. I'll talk about this in a later thing, but the POP2 has a thinning option that I typically use a lot when I have like millions of particles. I only want to see like just a few of them because it's very, very slow. And when you're not using it, make sure to disable it. But I digress. So now let's add here a random attribute. So what random does is it just creates a random attribute. So attributes are really important to understand, actually. I think I skipped that, but this is something that seems to be borrowed from Houdini. Houdini workflow is built very strongly on this. Points and primitives can have any arbitrary number of attributes. And that's why I like looking at what we have here. So P, and some of these attributes are built-in attributes, like P for position, N for normal. But a lot of other attributes you can have for like color, point size, and there's naming conventions for these as well, or you can have completely arbitrary. Like I could create an attribute, in fact, let me delete that. I'll create the attribute and I'll call it memo. And you see now every point is a memo attribute. And I'll give it a default value of 0.5. So every single point has an attribute called memo, which is 0.5. And let's randomize that. So that's a random. I don't need this anymore. I can say, instead of adding, I can say set memo, and it's between 0 and 1. So now every single point has a random memo attribute between 0 and 1. I can say make it between 10 and 20. So now every point has a random attribute between 10 and 20 called memo. Or I can say, give it a Gaussian distribution, a normal distribution with an amplitude of 0.1, centered around 0, etc. Anyway, let's reset this. We want to create an attribute called W, and let's say between 0 and 10. So there's W between 0 and 10. It's a float. I could click on this arrow here and say override automatic attribute and make it an int. So now it's between 0 and 10 and it's an int. It doesn't matter too much. We could have it as a float. But the key thing is then we can use these. This is a custom. I could let me call it memos W, just to emphasize that W isn't a special name. But you just need to remember what you've called it. And then here in my geo, in instancing 2 texture coordinates, if I click on this, I can see the attributes that each point has. Let's choose memos W. And you can see it's already worked. Like, it's that simple. Really, this whole thing, I waffled a lot, but actually this whole thing is like less than 10 seconds to set up. Okay, so that's the basis of it. Now let's get a bit deeper into pops. So let's start with the sign scroller, because that's a bit simpler. Let's create a line pop. And this line pop is going to be the backbone. So let's attach this to that and get rid of the point gen. We don't need that anymore. And the line in the points, so this is the coordinates of the left point of one point. This is the coordinates of the other point. Instead of 1, 0, 0, so it's going diagonally. Let's make that 1, so it's just going horizontally. Now the first thing we're going to need, so that's doing what we want to do, and if I do that, it stretches the thing out. But this is random. We don't want it to be random. let's create a text DAT. And this is going to be our, you know, where we put our text. So let's edit this. Hello world. So now what we want to do is here, the W, oh, first of all, also, this is just going from 0 to 9. We don't want to go 0 to 9. We want to go through the entire alphabet, so to speak. So this is going to be 255, 256, cache size 256. The reason is I'm just going to use ASCII, and if you're not familiar with ASCII, let's quickly. So ASCII is a kind of very old standard of assigning numbers to characters. And yeah, the first 32 are control characters, and then 32 to 127 are standard characters. So you can see a capital A is 65, a lowercase a is 97, space bar is 32, and then 127, or 128 rather, 128 to 255 is called the extended set. All of this is 8-bit, it fits into 1 byte, and then this extended set includes a bunch of these extended characters. And then in kind of more recent times, this was expanded to Unicode to add, you know, thousands more characters. But for now, let's stick with ASCII. So that's 255, 0 to 255, so that's 256, which is 8-bit. So let's say our cache size is 256, and here, what we want to do is use the Python command chr. Well, in fact, before we do that, let's just say we do this. And let's make the text a little bit smaller so we can see what we're doing. Okay, so I've made the font size 0.3, and in the text, this Python command is me time.frame %256. This is the modulo sign. It means divide by, and then give me whatever's left over. And let's convert this whole thing into an int. So what this is going to do is, this is just giving me numbers between 0 and 255, no matter what the, see if I come here, my frame number is 557, it's divided by 256, give me the remainder. So the first 256 frames are going to give me 1 to 256. I actually want the first frame to be 0, so let's do -1. Okay. So now the first 256 frames are giving me 0 to 255. When we do prefill, what it does is it runs this from the first frame for 256 times. So if I did prefill, now let's put a chr. This is a Python command, which means give me the character that has this ASCII code. So now when I prefill it, there we go. We can make it bigger now. So font C1. So some characters with the tails and stuff, like a G, like a J, see that's, if you do autofit, it doesn't seem to work. So no autofit, and then bring that down a bit. Yeah, in my experience, like 0.8 just about works. Okay, now let's prefill. Okay. This can go. And let's collapse this. And let's go in and add a out just so that we can see that there, just to be a bit tidier. Okay, so that's our text material. All we need to do is for each character here, we need to look up the index in this and then write that to the W, because right now when we do random, we get something like here in this random, let's say 0 to 255. Actually, let's say 65 to 65 plus 26. Okay, so they all turned white. Is this referencing the right material? Render, no. So this can't find that material. We need to say text mat. Okay, here we go. So when I put the fong inside this, it lost the link. So now my Geo1 in the render tab is referencing text mat fong1. The random, let's call this random W. I told it the random range to go from 65, because that's capital A, to 65 plus 26 to 91. So now it's the W values you can see are in that range, so we get random capital letters. If I made this 97, and in fact here let's make that 97 plus 26, now they're all random lowercase letters. So far so good, but we don't want random letters. We want the letters, we want the W's that come from this. Now, I couldn't find a non-script way of doing this. As in, I couldn't find a way of doing this without writing a simple script. But luckily, there's a very simple script that we can do to do this. And so let's add a script DAT. Where is it? So what this is going to do is this is going to run a piece of code every time this input changes. And because in our case this input is fixed, it's just going to run it once. But that's fine. So here's the code. Let's just drag this into here. So this is a lot of code to begin with. We don't need most of this stuff because this operator allows you to do a lot of complex things, like even set up a custom GUI and stuff. We don't need it, so we can get rid of all of that, and let's get rid of all of that as well. So we're left with just this. This stuff is commented out, but it's actually quite helpful. For example, this clears this. You can see that that's empty. If I uncomment this line, we have a row there that says color, size, shape, append row. So this is useful for us. Let's get rid of the other things. Oops. In fact, we want the append row. It doesn't matter, actually. So red 3 square. So this is quite easy. We don't want multiple columns. Let's just say hello. Hello, okay. So what if we want to go through this and print the characters? So for C in script op.inputs 0.text. So what does this do? This iterates through the script op, which is this, the first input 0, which is this, through its text, colon, and then this is Python, so we have to tab, indent, and then C. And now we have this split into letters. This is that pretty basic Python if you're not familiar. Yeah, this is iterating through the text, character by character, and then you have to indent in Python. That's just the way it is. So this command is being run for every character on the input. So this is almost what we want, but we don't want the letters, we want the numbers, the ASCII codes. So we want to use the opposite of CHR. If you recall, we had, CHR is from character to ASCII code number, and the opposite of that is ORD. This goes number ASCII to character. So let's just put this as ORD. There it is. So that was pretty simple. We can close this now. Okay, I'll leave it open so you have it to read the code. And let's convert this to a chop, that to chop. And I want to make it single channel. first column is values. Okay, so this is basically for every row here, we have a sample here. Alt-N, add a null. Let's call that null W. So instead of random W's, we now want to use that. And let's get rid of that random. This is giving an error because if I middle click, instance attribute memos W could not be found. Yeah, because I just deleted it. Let's add. So what we want to do is we want to look up the W from this chop. Luckily, there is a lookup attribute, lookup channel, lookup texture. We'll use the other ones later, but for now we're going to use lookup channel. And what we want to do is we want to use this. So the chop we want to use is that. So let's put that there. This is the chop we want to use. Let's just jump to the bottom first. What is the attribute output scope? What do we want to write to? We want to write to W. Actually, I think I called it memos W. Memos W. So now this error has gone away because we have this memos W. We have it now. This is creating it. In fact, if you zoom in to these pops in the bottom left, it'll show what attributes are being created in that. Here, this is quite handy to see. If I create test, you can see it says test. Any attribute that is created in a pop, it says the name there. So anyway, this lookup chan is looking up in this chop here, null W, writing to memos W. It kind of looks almost correct, but it's not exactly correct. Now, why is that? This is really important because how is it mapping this chop onto these points? That's the question. First of all, how many points do we even have? This line, if I middle click, it has 22 points, 21 points. Whereas, how many letters do we have? Let's click there. We have 13 letters. So for one thing, this is not got the right number of points. So if you look here, there's too many letters, right? That's more than hello world. So let's fix that. Divisions, we have 20 divisions. You see that we have 20 divisions. Now I'm changing that. We want 13. But we don't want to do this manually. We want to do it programmatically. So I can, on this, add an info. And here there is, where is it? Length 13. So let's use that. Length divisions. Is that right? H-L-L-O. Oh, we'll see. It's still not correct. We're still not seeing hello world. And the reason is because this lookup attribute, which says which attribute of this data should we use to look up in this chop. At the moment it's using X position. We don't want to use X position. What that means is if I change the length of this thing, the characters are going to change because it's using the X position, the world X position, as a lookup index inside this chop. No, we want to use the number, so that should be 0, that should be 1, that should be 2, that should be 3, that should be 4, that should be 5, etc. So we want to use what are some hidden attributes. So when I click on this, you can see there's P. There's P.io1, we'll get to that later, but there's also this that you can expand, and there's all these names that begin with underscores. These are hidden, built-in default attributes. Underscore point I is the point index. Underscore point U is the normalized point index, 0 to 1. So that would be 0, that would be 1, that would be 0.07, etc. We want underscore point I. Lookup index units, so we need to say sample index. And there we go. And there's 2 exclamation marks. Why is there 2 exclamation marks? because in the line number of divisions, this is the number of divisions. Let's say that I made this 3. So there's 3 divisions, but there's 4 points. So we want the number of points to be equal to 13, not the number of divisions. Right, so let's go back to our thing. So we want to do that -1. So now there's 12 divisions, which will make it 13 points. So here we are, hello world. And let's try putting some longer piece of text in. This was a classic in the demo scene. So let's put that there. Okay, so it's put it in there, but it's really, really squashed. So what we can do is let's create a constant. And let's call that spacing. And add a null. Call it null params. So here in the coordinates of that point, we can drag and drop, this as a reference, times, let's get this parameter. So it's called divs, right? Divs times me.par.divs. Now let's go back to this. Okay. In fact, let me do that. Let me put this here. Show you this. So this is the point position. If I get rid of that, you can see that that's updating as I write. The point position changes. Okay, so that's spacing. Let's put this back in. Okay, cool. Let's say, and now we want it to move up and down. It's quite easy. There's a lot of ways to do it. Let's move that up. Let's create a pattern. Yep, take that. Let's add a null. And let's call it null y. And let's create a new lookup channel. The chop we want to use is this null y. And what do we want to write to? We want to write to the vertical position. So that's p.y. Okay, something's happened. So we have it a little bit there, but not fully. So again, we need to think about the lookup attribute. Right now, it's using the absolute x position. So if I were to, for example, here, let's add right here, a transform, and move this whole thing to the left, you can see as it's moving to the left, the sine wave is staying exactly where it is. Let's get rid of that transform now. To not get confusing, this lookup chan is looking up w. Let's immediately rename that to lookup chan w, and this one is lookup chan y, because otherwise it's going to get very messy. There's a few things we can do. Let's try, instead of position, let's try again point. Let's do point u. So now it's applying the sine wave throughout the whole length of the text. This is also not what we want, because if we make the text really short, then it's applied it to that, and as we add more text, it's going across the whole thing. But we could put it over the point index and not normalized. The problem with that is it's going to be, you know, this is 0, 1, 2, 3. We want a way of controlling the frequency. So let's add another constant, call it wave, call it wave frec. And I don't know what it needs to be. Let's say something like 0.1 for now. What we want to do is we want to apply this sine wave over the point index, but multiplied by this wave frequency. And to do that, we need to create another custom attribute. So the way to do that in this case, because this is going to be a mathematical attribute, instead of just creating a custom attribute with a constant or doing random, there's a super powerful thing, which is these math pops. There's math combine and there's math mix. And basically, they're quite similar. This is what math mix looks like, and I'll create a math combine as well. Basically, this is math mix, this is math combine. You can see that the math combine has a bunch of extra tabs like new, pre, and post. Basically, the combine tab is identical. The uniforms tabs, I think, are identical. But the combine you can create attributes and do some pre-processing and some post-processing as well. So I'm going to use, I don't think we need it, but I'm going to use the math combine just in case I do need to do a before and after. So here, the way this works is the combine thing is you choose an operation and then you give it a name. So if we want to do A times B, what we want to do is we want to multiply the point index with this wave frequency, and let's write it to a new property. Let's call it wave lookup. And if you look here again at our pop, wait, is that looking at the right thing? Yeah, there it is. Okay. So every point on this line now has a wave lookup. So now in our Lookupchan, instead of using point I, we can use wave lookup. Now, let's go back here and let's play with this. So now I can control the frequency. You will notice that it does one cycle and then they're flat. The reason is in the Lookupchan, extend left, right, it's hold. Let's make that cycle to the left and cycle to the right. Okay, there we go. Now I can control the frequency in space. I cannot in space, over the indices of the characters. So if I change the text length, it's not going to have any effect on my frequency. Right? So that's for the X, that's for the Y, sorry. Let's do one for the X. Now, I could just copy this, you know, put that there. I could copy that, do it for the Z, and then, you know, copy this, and then do another one, and do that for the X, and then look them up individually. But there is an easier way, which is, let's call that one pattern X, pattern Y, and let's merge these. I want this to be another, and I'll call them actually like TX, TY. The names don't have they don't make a big difference, but it's just easier to read. And then let's call this null offset. What's the error? Oh, we can't add null offset to p.y because null offset has 3 channels, p.y is a single channel. So that's what the error is. If I got not enough output components, ignoring extra input components. So if I just say add this to p, now it's adding it all to p. But notice that we just have this diagonal line now. Now the reason why it's a diagonal in that perfect thing is because the x and the y and the z are all identical. So the reason why I created these as separate things is because we can control, we can control the x, y, z separately, and the amplitude, etc. Let me just undo that. But the main problem is we're not actually adding to the x or the y or the z. If you look up what's happening here, if you recall this math combine, again, first let's rename it. What is this math combine doing? It's, I'll call it math wave lookup. This is no longer the Lookupchan y, it's the Lookupchan pause. See, what it's doing is it's using the attributes that we created here to look up in this chop, and then it's writing to p. So it's overwriting p. We don't want to overwrite p, we want to add to p. So how do we add to p? It appears that in this UI we can't do that. What we can do is we can write to an arbitrary new attribute. Let's call it pos offset. And let's rename this for readability. If again we look at our POP, now you can see that we have, why is this, this doesn't seem to be updating very nicely. Let's try that again. Okay, yeah, I don't know why it's not updating. Maybe it's a bug. This is an experimental version of Touchdesigner. So now you can see that every point on this line has a wave lookup that we created here. Now it has a pos offset, which is a vector. And so now we need to add another math. Let's do a math combine again. Now we want to do a plus b. We want to do position plus pos offset, and we want to write to position. That's the default. So it's writing it to, if you see that's empty, we can choose, but yeah, it's writing to p. And now we can see that this is working. So now it's sinusoidal in y, x, and z. The phase is all the same, it's in sync. That doesn't look very good, but like if I go and I make my z amplitude 0, you can see it's flattened. If I make my x amplitude 0, now it's just on y. I can increase the x, decrease the y. So now I have independent control. If we make the x cosine instead of sine, then it's going to be in circles. That's just the way circles work. I mean, we could also flip that and make that sine and make that cosine, and it would still be circle. Because cosine and sine are 90 degrees out of sync. Let's go back to the constants and play with our wave frequency. And I can control the thing. Now let's go back and let's make the z cosine and give it a bit of amplitude. And let's go back, make that sine, make that cosine, and make the amplitude a bit less on that. The key interesting thing again is we can play with phase. Phase is where it is in that cycle. And of course one thing we can do is, let's just type abs time.seconds, make it move through a bit fast. Divided by 2. No. Yeah. Right, let's copy that. Just find. Okay, so that's creating a nice corkscrewy type effect. Let's add a bit more amplitude on the Z. Now the last thing to do is to make it scroll, and that is pretty straightforward. Let's add a transform. So with the transform, we just want to move it on the X. That's move on the left, etc. So I'm going to move this out of the way for now. Let's create an LFO chop and add a null, and let's call that xpos. And in the transform, let's just drop that there for now. So now it's just moving back and forth. We don't want this to be sinusoidal, we want it to be a ramp. So it's going from 0 to 1. Let's make the amplitude quite big. So this is going in the wrong direction. So in the transform, I'm just going to put minus. So it's going to the left and then it's cutting. There's a few things that we want to tweak here, which is how far should it go, and then where should it reset back, and how fast should it go. How fast it should go is the frequency. So if I make it slow, it's moving slower. And then there's also the extent. So on this transform, let me just not undo, but cancel that. So let's say we want it to go, oh, that was too much. We want it to go about there and then reappear. That's minus 90. But this depends on the length of it, obviously, and also where we want it to reappear. We want it to reappear not at 0, but we want it to appear off screen, like maybe somewhere there, 10. So as far as it's going off screen, we said we want it to be around, say, minus 90 when it goes to minus 90. Now that is actually related to the length, which is this. So we can see that the right point is at 85. So let's just add an arbitrary 10 to give it a buffer. So we can just add a math here. We want to, so the amplitude, let's make the amplitude 1. So this goes 0 to 1. And let's re-enable this. In fact, we don't need to put the minus there. Let's keep the minus off, because we can do it in the math. So now we have the LFO going 0 to 1. It's a linear ramp with some frequency. And in the math, oh, okay, nice. In the math, we want to do a range. We want to map the range 0 to 1. The 0, we want it to be about 10. So it starts about there. And then the range, we want to take this. Let's copy that. And here, let's paste that as a reference. That we want to be minus, and we want to also add, or let's add an extra 10. So there we go. Let's slow this down by, actually let's put this here and shorten this text. So I guess get rid of that. So now all that's left is to adjust the speed. The thing with the speed, it's also going to be dependent on the number of characters, because this LFO maps the whole, like this is maybe a reasonable speed for this, but if I put all of that all that text back in, this is way too fast. So we want a speed parameter that is independent of the length. So again, let's go back to our constant and add a scroll speed. And I don't know what it should be for now, but let's say 1. And then here, we could just take this Alt-A, drag, drop. And then we want to make this depend on the number of characters. The number of characters we have here, it's info length. And we want to divide by that because frequency is the opposite of duration. So it's like how many times a second. How many times a second we want it to do is 1 over the duration, and we want the duration to depend on the number of characters. So let's take op info1. So this is one gripe I have. It's a shame we can't, by the way, drag and drop this, that we can't drag and drop, where was it, length here. It's going to overwrite that. So sometimes what I do is I might drag and drop this length down here to offset, then open that, cut it, put that back to 0, and then put that there. So the frequency is basically the scroll speed divided by the length. So that's way to, let's say 10. Okay, that looks like a reasonable speed. Okay, this is actually getting quite long, so I'm going to start wrapping up quickly. So let's call that transform x scroll. And just to show a few more things quickly, and then the rest can be in another video, just to show how to create, for example, scale. Actually, there is a convention. It doesn't have to be called point scale, but the convention is in Touchdesigner, you call it point scale. And let's call it, let's say, make that 1 for now. Let's make it 2. So then in the geo instancing, this is just standard. Again, you can say point scale. You can see that. So now if I change this, you can see how it's affecting the scale. And if you, let's call that utter scale. And one thing I will show, I'll talk more about this in the next video, that noise. So we all know noise from various things, the tops, the chops, here's the amplitude. The really powerful thing is by default here, the noise is, adding a lot of noise. We can play with the period. You're probably familiar with this stuff from, we've got the noise top, and we've got the noise chop, and the noise SOP, which needs to add something. So this is basically the similar maths. But the very interesting thing is, first of all, what it's using to look up the noise. So what is if you imagine, let's look at, this is, let's create a noise. This is a noise top. The lookup is what in this it's looking, what coordinate or what attribute is it using to look into this. So at the moment it's using P. I could again use, so actually one thing, here we don't have those underscore attributes, the hidden attributes. We only have those in the math. I don't know why. Derivative, if you're listening, it would be nice to have them here. Maybe there's a performance reason. So here I can't actually say point I. It's going to give an error. Or I can't use point U. If I do want to do that, I would have to create it, use like a math combine, and then just use A, just as is. And I say, for example, the point U, save that as ID norm, so normalized ID. So this is, I'm now copying this attribute, which is only available to this node. Look, if you look here, there is no underscore point u. That's permanently stored. Let's just disable that for now. But I'm writing that to ID norm, and now there is an ID norm. An ID norm is just a normalized 0 to 1 attribute of the point. Now in my noise, I can say use that, use my ID norm. So now it's, instead of using the position, it's still applying the noise to the position, you can see, but it's, because if you look at it, you can see, let's make the, you see, it's still applying the noise to the position, but it's using the normalized index to look up into this. Let's make the harmonic small. But actually, I could apply it here in output to something else. I could apply it to the scale. So now it's applying it to the scale. I could, let me go back and I choose P. So now it's using the position as the lookup, but it's still applying it to the scale. We'll cover this in more videos, that this stuff is really powerful. The problem of applying it to P is as it's moving through space, its P is changing. So you might, if you don't want the scale or the color to change as it's moving through space, then you don't want to use P, you want to use something else. So let's use ID norm. Similarly, let's create another noise. So this is math combine. I'll just call it ID norm. This is applying noise to P scale, point scale. Finally, that's a bit much. Let's make it 1. Okay. Finally, let's add another noise and let's call this C col. Here again, we want to use ID norm, and we want to write to color. There is no color. We haven't created a color yet. Because we haven't created a color, we can't add to color, but we can do none. Sorry. Oh no, we can't set here. Combine. No, we can't set. So I'm going to create, let's just write attributes, make a fixed. And we can choose, we can create a custom arbitrary attribute, if you remember, like, blah, and there it is, blah. Or let's choose, color. This is one of the built-in ones. So now we have a color. Let's make it pink. We're not seeing it because we're not using it. So in the geo instance 2 color, let's set the colors, set these colors. RGBA. And now you can see it's got a pink tint. Let's call that attribute color. Actually, let's call it attrCol. And now we can add to the color. So now this noise is adding to this color. And the lookup is the ID norm again. So over the length of this, it's adding just a subtle bit of variation. But we can play with the period. So if I make the period smaller, let's make it quite clear. So I've made the amplitude 1. And now if I make the period 1, then the noise is applied to the full length of this thing. But if I make the period lower, it's got a bit more, you know what I'm talking about. Okay, I'm gonna stop there because I think I went on really long. This was my first video, so sorry for that. In the next video, I'll cover the grid and how the grid explodes into the ball, and basically, yeah, this is what we'll do in the next video. Okay, thank you.